Hello everyone, in this video I am going to teach you the introduction about polynomial functions. Of course, let's begin with the definition of polynomial function. So a polynomial function is a function in that form, where a sub n minus 1 until a sub 0. So here basically we're just talking about the numerical coefficients of the variables and the constant. They are real numbers, and so when we say real numbers, it can be irrational numbers or rational numbers. Generally speaking, it can be negative or positive. It can be fraction. And this n right here is the exponent. N is a non-negative integer. Now, one thing we should also remember that the domain of a polynomial function is the set of all real numbers. Okay, so let's have a quick exercise. Let's determine if the given um, expression or function is polynomial or not. This one. Okay, that is right. That's a polynomial function. How about this one? Okay, so that is right. It's not a polynomial function because of the fraction 1/2, which is the exponent. It cannot be a fraction. Okay, although 1/2 is positive. How about this one? Okay, that's right. It's a polynomial function. This one. Okay, that is right. It's not a polynomial function. So basically this, we can express that as like x raised to a negative x raised to 1/2. So it's going to be a fraction, right? So, but if you see like a variable in the radical sign, then it's not considered polynomial function. Here, absolutely right. That's not a polynomial function because of the -2. Take note that the exponent is a non-negative integer. Okay, so it's an integer, a non-negative integer. So it cannot be a fraction, right? Here, that is absolutely correct. It's not also a polynomial function because of this. Why is that? Because we can express this as 2x raised to -3 by the loss of exponent. So we have here a negative exponent, so that means it's not a polynomial function. How about that one? Okay, that is right. It's a polynomial function. This one, okay, that is also correct. It's a polynomial function. This one, okay, that is right. It's a polynomial function. This one, okay, that is right. It's a polynomial function. So here we can, I know you're kind of thinking, what is that? I mean, you can express that as minus 1/3 rather, x raised to 3. And negative 1/3 is a real number. Okay, so let's just summarize. So basically, the thing here is that we just need to determine which one or what makes a polynomial not a polynomial. So remember these four things. Number one, if you see this like a variable inside a radical sign, it's not going to be a polynomial. Similarly, if you see an exponent that is a fraction, it's not a polynomial. Take note that the fraction should be a non-negative integer. So therefore, this is also not a polynomial. And also this one, if you see a variable in the denominator, it's not polynomial functions. So once you see this in a function, automatically you will conclude that it's not polynomial. Okay, a variable inside a radical sign, an exponent that is a fraction, an exponent that is a negative number, and a denominator that is a variable. Okay. In polynomial functions, there is a term called degree. Okay, now in math, degree means two things. Number one, in geometry, it is a way of measuring angles. But in algebra, a degree of a polynomial, okay, is the highest power in a polynomial. Please take note of that. The highest power of polynomial. And later on, I will show you the different classifications of polynomials according to its degree. Okay, but here, how will we know the degree of polynomial with one variable? Okay, let's go back to the definition. So a degree in polynomial is the highest power in the polynomial. So here we have 2. So we will call number 1 as a second degree polynomial. And that x raised to 2 will also tell us the leading term in a polynomial. So basically, x raised to 2 is the leading term, and the numerical coefficient 1 is what we call the leading coefficient. So 3 things we can learn here. Number 1, the highest exponent 2 will tell us that x squared is um, the leading term, and 1 is the leading coefficient, and we call this a second degree polynomial also. Okay. This number 2, okay, what is the degree of the polynomial of this one? That's right. It's a fourth degree polynomial. So since this is a fourth degree polynomial, we call negative 2a raised to 4 as our leading term and negative 2 as our leading coefficient. Next. Okay, here we can call number 3 as a seventh degree polynomial, or we can classify number 3 as a seventh degree polynomial. And negative 8n raised to 7 is what we call the leading term, and negative 8 is the leading coefficient. This one, okay, that is right. This is a fourth degree polynomial. The leading term is 5x raised to 4, and the leading coefficient is 5. This is the last one. This is an 8 degree polynomial, and negative k raised to 8 is our leading term, and negative 1 is the leading coefficient. Okay, so this is how we classify polynomials if we have one variable, degree of polynomial with one variable. Okay, so what if you encounter a polynomial that has more than one variable, such as this one? How are we going to determine the degree of polynomial? So for this one, we will, excuse me, we will compare all the exponents. So this is raised to 2, this is raised to 3, and then we will consider the two variables here, x and 1. We know that this is 3, but the exponent of x here is 1, right? So we will add 1 plus 3, and that is equal to 4. And then compare which one is the highest, 2, 4, or 3. Obviously 4, so number 1 is classified as a fourth degree polynomial. Okay, so we need to add the exponents in of the variables in a term. Okay, if there's more than one. Like, okay, here we have a and b, so let's add 3 plus 2. Okay, and that's 5. Okay, this one is also 5 because of 1 plus 4, and this one is 3 because of 2 plus 1. So this is a fifth degree polynomial. Okay, this one we have 1 plus 5 is 6. This is just 3, and then this is 7. And obviously 7 is the highest, so that's number 3 is a seventh degree polynomial. Okay, let's go to the next one. Here we have 1 plus 2, that's 3. 3 plus 1 is equal to 4. 2 plus 4 is equal to 6. The highest is 6. So therefore, number 4 is what we call a sixth degree polynomial. Next is the last one, I think. This is 7. This is 8, and this is 1. Okay, the highest is 8. So therefore, we call number 5 an 8th degree polynomial. Okay. Now, let's go to the different classifications of polynomials. This one is the classification of polynomials according to their number of terms. So we have 3x, and by the way, what do you mean by term? Term is composed of a variable, but it can also be just a constant. And sometimes there is, of course, there's an exponent, right? Like that, this one, 3 raised to 1 and x raised to 1. So it's composed of a numerical coefficient or just a number and a literal coefficient or a letter. Sometimes it's just a letter, okay, or a variable. One way to determine the terms is just it's separated by plus and minus. Okay, so like in this case, 4x and 1, they are separated by minus. So we call this binomial because there are two terms. For number 1, that's a monomial. And then here we have trinomials, okay, because there are three terms here. And as I mentioned earlier, terms are just separated by plus and minus. So this is x raised to 3, that's 1, negative 2x, that's another one, and plus 7, that's another one. Now, generally speaking, all of these are called polynomials, okay? But they are being classified according to the number of terms. And then we can also classify polynomials according to its degree, just like a while ago what we did. But this time, there are names, specific names of these functions. Like if it's just a number, we call that a constant function. If the degree is 1, okay, first degree polynomial are linear functions. Second degree polynomial are quadratic functions. Third degree polynomial, we call them cubic function. And then a fourth degree polynomial, we call them quartic functions. And then fifth degree polynomials, we call them quintic function, right? I know. But generally speaking, these are all polynomials, okay? So there you go. That's the introduction of polynomials. See you in my next video.